All right, number 19, we want to use for the system, determine if there's a steady state, and we're going to state the steady state value for a population of squirrels, and it's given by this function. So we have P of t as our function, and that is equal to 1600 divided by 2 plus 7 e to the negative 0.04 t. Okay, so the best way to approach this is to think about some of the properties of finding a limit. So we're going to do the limit as t goes to infinity. When we do limit, if you recall some of the properties, the limit of a quotient, so you can separate this and do the limit of the top and the limit of the bottom is the quotient of the limits. And then in the denominator, we have a sum, so we can also break this up and use the sum of a limit is the limit of the sums. And so we're going to write each of these as its own separate piece. So I'm going to say limit of 1600, and then that's going to be divided by the limit of 2, and plus that's going to be limit of 7. And since this has a negative exponent, I'm just going to rewrite this and just put it in the denominator. So make a fraction down here. So this is going to be e to the positive 0.04 t. Okay, so I got 3 different limits, and I can evaluate them all individually. So as t goes to infinity, there's no t here, it doesn't affect it, it's just a constant function. So on the numerator, we're just going to be left with 1600. Sorry, some of that is kind of off. On the bottom, limit of 2, same thing, there's no t affecting this part, so as t goes to infinity, this function is staying constant at 2. And then here, as limit goes to infinity, e is like 2.7 something, so let's just round up to 3. As you take 3 and just raise it to bigger and bigger and bigger power, the denominator of this is getting really, really big. 7 is staying constant, so this whole term right here is just going to 0. So at the end of the day, we are just looking at 1600 divided by 2, which is going to give us 800. So as this function goes to positive infinity, we are going toward 800. So we do kind of reach a steady state or a limit. Now, if I think about the opposite, and we want to take this limit as t goes to negative infinity, what happens? So thinking about the same scenario, the top is just going to go towards 1600. This part is still going to go toward 2. However, when I plug in a negative number, this will go back up, and I'll be looking at 7 e to the negative 0.04 times 2. So when I plug in a negative, it's going to cancel out the negative here, so it won't go on the bottom. It'll just make it just like this. This number is just going to go to infinity. So as this number gets bigger, plus 2 is not going to be irrelevant. It's going to be irrelevant. So the bottom of the fraction is shooting off toward infinity while the top is staying constant. So this overall fraction is going to go to 0. So we're going to be looking at going up to 800 as a max, and then 0 as I go toward negative infinity. So it looks like we only want to look at positive infinity, and so the one that matches, we do approach a value, so we'll say k, and then the k value that we approach was 800. State the function has a steady state value. Why did I type 400? 800. Hit the wrong button.